Welcome to Physics Can Be Fun with me, Stephen Thomas. There's a section of work in the chemistry paper 2. Question 4 normally, it involves flow diagrams and it involves various changing one organic compound into another. So let's have a look at, say we have a molecule like that and we add something to it and we get a different molecule. Now that's question 4. And I, for the sake of any better name, am calling it flow diagram. So let's suppose we have a 3-carbon compound. It's got a double bond. What is it? Methane, ethane, propane. But it's got a double bond, prop 1-ene. So anything with a double bond, it's an alkene. Propene. And let's suppose we break that double bond there. That bond goes up. That bond goes up. Because we've broken the bond, we can now add things. So this is called an addition reaction, because we can now add things. So let's suppose we add hydrogen. So we can put as our new hydrogen, let's draw it in a different color, H there, H there. So this bond breaks and there we add another hydrogen, there add another hydrogen, and now each carbon has got four bonds and 4 hydrogens. Well, 3 hydrogens, but there's 4 bonds. So we call, if we add hydrogen, we call that hydrogenation. So it's an addition reaction because we're adding stuff and we're adding hydrogen. You'll notice that this goes from double bond, which we say is unsaturated, to single bonds, which we say is saturated. And that is an addition reaction when we break a bond and add something to the now, and we end up in a molecule that's only got single bonds. So if we add hydrogen, hydrogenation, let's suppose we add, say, chlorine or bromine or iodine. So then we're adding halogens. Then this is called halogenation. So that's when we're adding the halogens or the group 7 compounds. So instead of, say, having a hydrogen there, we might have, for example, let's suppose we have chlorine. So let's get rid of the hydrogens and let's make this chlorine. Chlorine. We're still adding something, so it's an addition reaction, but we're adding halogens, halogenation. And so there we've got now our 2 chlorines instead of hydrogen. Or what if we add, say, HCl, which is a combination of hydrogen and a halogen, then we get hydrohalogenation. So it's still halogen, it's still an addition reaction, but it is called hydrohalogenation. So, because it's got a hydrogen and a halogen. We could also add a water, and then we get hydration. So let's put that there, H2O, hydration. And because we're adding it, because we're breaking a double bond, we're forming single bonds, let's put our water here. And there we would get our water molecule added on. And now that would be an alcohol. So there we've got 4 types of addition reactions. Now, if we can go from that to that, we could also go the reverse way. And so instead of having an arrow where the hydrogens, the chlorines, the hydrogen and a chlorine or the water get added, we could go the reverse way, where in fact they get lost from these compounds. And then instead of it being an addition reaction, that would be an elimination reaction. So it's no longer addition, it's elimination. And just as we had hydrogenation, we could have dehydrogenation. dehydrogenation. That's where this would go, lose its hydrogens and go back to forming a double bonded alkene, propanene. Or what if we had two halogens on here and we went the reverse way, dehalogenation, or if we lost from an H and a Cl, dehydrohalogenation, dehydrohalogenation, and likewise we could also lose the water. If we were to lose the OH and H, it would be the opposite, dehydration reaction. So there we have addition and elimination reactions. Now normally it's easy going this way because double bonds consist of 2 electrons in each bond shared covalently. That's forcing 4 electrons into close proximity in the double bonds. So they far prefer to be as far apart. You see these lines are as far apart as possible. Normally 107 to 109 tetrahedron shape in reality. It's for the double bonds and the single bonds, the electrons want to get as far away from each other as possible. So going from this double bonded, where the electrons are forced into close proximity, to this single bonded saturated state is normally fairly easy. You just have to add those and it'll go from that to that. Takes a little bit of persuasion to add hydrogen. Normally we've got to dissolve that in a non-polar solvent, and then we've got to have a hydrogen-rich environment, and then it will add the hydrogens onto it. Or if we adding the water, we may need a strong acid or some kind of catalyst to force it to go from there to there. But forcing them backwards, they don't want to go from this unsaturated state to a double bonded state, from the saturated state to an unsaturated state. In other words, they don't like going from single bonds to double bonds, so it's going to take a lot more heat, catalyst, or some sort of forcing to get them to go from that to that. Let's stand to this side. Let's suppose we are trying to undergo halogenation or hydrohalogenation, anything with a halogen in it. We're going to find that we basically just have to add the chlorine, bromine, iodine, or the HCl, HBr, HI, and we are going, if we're doing addition reactions, we just add it to that and it will form our product. Not much coaxing required. If, however, we are doing hydration, we've got to have an excess of water, that means quite a bit of water, and then we need something that's going to be a catalyst. So maybe we're going to need a little tiny amount of a hydrohalogen to be the catalyst to get the water to combine and form, adding the water here. Now what if we're doing hydrogenation? That takes a bit of coaxing, so we're going to need a catalyst. We're going to need platinum, palladium, or nickel catalyst, and then we're going to have to bubble hydrogen through that solvent over the platinum catalyst, and then it will go to form, it'll add the hydrogens to our propanene. Now let's continue with addition. Let's suppose we're doing hydrohalogenation. We're going to add HCl to this propanene. Does the H go there, or does the H go there and then the chlorine would go on the opposite one? Now there is a rule called Markovnikov's rule. Markovnikov. Now the rule is this: whichever carbon has got the most hydrogens will get the hydrogen. So we're adding HCl. That's got 2 hydrogens, that's got 1. So this one's got 2. It will get the H from the HCl, and then this one, which has got less hydrogens, will get the Cl. So it's almost like you hear in biblical, there's a verse somewhere which says, to him that has shall more be given. So to the carbon that has hydrogens, more shall be given. Now the reverse is also true. Let's just suppose that we are doing an elimination reaction. And we are in fact doing dehydrohalogenation. Dehydrohalogenation. We're doing elimination dehydrohalogenation. What are the reaction conditions required to get rid of the H and Cl? Well, it's going to require heat because it doesn't want to go in that direction, doesn't want to go. So the heat in a closed or reflux vessel where the vapors can continue boiling around. And we're going to have something that's going to persuade the H and Cl to come off. So we've got to have concentrated sodium hydroxide, NaOH, in concentrated or pure alcohol, say ethanol. So we're going to have that in alcohol. So that in alcohol will persuade that and that to come off. So we're going to have to heat it, have the sodium hydroxide or potassium hydroxide in pure alcohol, in the heat. It's all refluxing or boiling the vapors, and then we can persuade the chlorine and the hydrogen to come off, and we can go back to the double bond in an elimination reaction. Elimination, we're forming a double bond. Now let's suppose that we have here another chlorine. And we're going to take one of these chlorines and one of these hydrogens off, and we're going to get a dehydrohalogenation reaction. So which of these carbons is going to lose the chlorine? Now the rule is, and the hydrogen. The rule is you again look at which carbon has got the least hydrogens, and that is actually the one that is going to lose its hydrogen. So it's going to be this carbon number 2 that is going to lose the hydrogen, and that carbon which has got 2 hydrogens will use the chlorine. And so when it goes the reverse way, so it's going to go to form this plus, there's going to get HCl. So we're going to find that this hydrogen will be lost and that chlorine will be lost, and then it will form its double bond. But the rule is the carbon with the least hydrogens, that is the one that will lose the hydrogen. The one with the most hydrogens will keep its hydrogens and lose its halogen.